Assalamualaikum and good morning, students. Okay, so we continue our chapter 5. Okay, so we will move to Anova, and this is our variance. So I will show you the slideshow. Okay. So, another variance of ANOVA is for comparing the mean of two different populations with Z and T statistic. Okay, to compare the means of more than two independent populations, ANOVA is applied. So before this, we are using the T and Z, okay, test. But that one is for one sample and also for two sample. So ANOVA is applied for the population more than two, okay, more than two independent population. So it analyzed the variance in the data from different sample to determine whether all populations mean are equal or not. Okay, so we want to check whether the mean of the population or sample is equal or not. Okay, that's the simple hypothesis for the ANOVA. So if you look at the ANOVA, okay, hypothesis, we will apply for all types of questions for the ANOVA. For example, for the null hypothesis, mu1 equal mu2 equal until mu m. So if your sample have three, if your population have three, meaning that your mu should be have three also. Okay. If you have four, then four mu. All right. So alternative hypothesis, at least one of the mean is different from the others. Okay. For the ANOVA, we have the assumption. Okay, so number one is the population follow the normal distribution. The population have equal variance. The population are independent. All right. So we go to the example 5.6. Open your Excel for the ANOVA. Okay, so we will do the exercises. So this is the data for the ANOVA exercises. Okay, so I will read the instruction from the textbook. An analysis is done on the dividend yield for stocks of three different subsectors in the financial services sector listed in Bursa Malaysia. The analyst would like to know whether any of the subsectors has a different dividend yields from others. Okay, so we have here insurance, banking, and also other financial. So we want to look at these three different subsectors whether it has difference or equal. All right. So the first step is always the hypothesis statement. Okay. So we have three population. Okay, so meaning that our mu is also, we will have three. Okay, three mu. Okay, mu1 equal mu2 equal mu3. Okay, then we will have the alternative hypothesis. At least one of the mean is different. All right. Okay. So for the ANOVA, we also can use the data analysis. Okay. So go to the data analysis and searching for ANOVA single factor. I think this is the first one in the analysis tools. Okay, and then click OK. So the input range, you just highlight all the data. Highlight all the data including the label. Okay. So tick the label since we pick up the data from the label and just click OK. All right. Okay. So from here, okay, the important value is actually an F, okay, P value and F critical. Okay, so this is actually the test statistic. Okay, this one is P value and this is the critical value. Okay, so from here we can see that, okay, we can see that we fail to reject our null hypothesis since our p-value is more than 0.05, and also the test statistic is less than the critical value. So what will be our decision rule? Just write decision rule. Okay. Okay, since f test is 1.45, okay, less than critical value 3.369, thus we fail to reject the null hypothesis. Sorry. And another one, since p-value is 0.253 more than significance level 0.05, thus we fail to reject the null hypothesis. Okay. So we have our decision rule, and look at back at our hypothesis since we failed to reject our null hypothesis. So we can conclude that all the means are different. Okay. So what will be our conclusion? Okay. It can be concluded that the dividend yield for stocks of three different subsectors in the financial services sector is equal. Okay, since we fail to reject, then the mu for all these three banking sector, okay, dividend yield for all these three banking sector is same. Okay, but if we reject the null hypothesis, then the H1 is your conclusion. Okay. All right. So that's all for Anova. Okay. So I see you for the next video for chi-square. All right. Thank you, everyone.